Hi. So, something that I've noticed a lot of my high school students struggle with is quadratics. Solving them, graphing them, just freaking out about them in general. So, I decided to put forth a video or a couple of videos on how to deal with them and stop freaking out. First thing you need to know is there's just some step that you're not getting. It's not that you're dumb, it's not that you can't do it, it's just that there's some step that you're having trouble with. And that's what this is for. I'm hopefully going to clear that up for you so that you can move on and keep going, because math builds on itself. You need to know how to do each step in order to do the whole thing. So, there's just some little place that you're stuck at, and when you get past that, you'll be surprised how much better you'll do. So when I say quadratics, something like y equals x squared. The square is what's really important here, because when dealing with polynomials, the degree is what really matters. So if I add x to the fourth plus 3x plus 2, this is a polynomial. The degree is the highest exponent you have. The 4 is the highest exponent here, so this is a fourth degree polynomial. Quadratics are second degree polynomials. They have the highest exponent is 2. The reason I said y equals x squared is because it is the parent function of quadratics. Parent functions, if you haven't gone over them yet, are important because it gives you the basic graph of a function. This one makes a parabola. So we're going to graph this. We'll make our t-table, and we'll use some different things to plug in. I like 1, 0, and negative 1 just because that usually gives you a good idea of what something looks like, especially parent functions. So I would plug in my 1. What is 1 squared? 1. 0 squared? 0. Negative 1 squared? Also 1. So if I was to graph this, I would go over 1, up 1, 0, 0, which is the origin, and left 1, up 1. Now, if you'll excuse my extreme lack of drawing skills, you can see that this makes a U shape. This is called a parabola, spelled like this. My terrible handwriting, but I promise it's spelled right. So, a parabola makes this U shape and has a lowest point called a vertex. We'll get more into that later. Right now, just know that quadratics will make some kind of U. Now, they can look like this, they can look like this, they can look like this. Lots of different shapes, just like any function, but this is the most basic kind. Now, the reason that parent functions are important is because no matter what kind of function that I draw that is that same type, or in our case, quadratics, it's going to be some variant of that. Like if we had 0 equals x squared plus 5x plus 6, it's still going to be some kind of parabola. It's just going to be a little funky looking. It might be stretched out, it might not touch the origin, it might not cross the x-axis at all. It's going to look like something, but it's just some kind of variation from it. It's a transformation. So, let's take a look at that one in just a little bit more detail. We have x squared plus 5x plus 6 equals 0. Now, it being equal to 0 is very important for when you're solving it, because you may have guessed already, we're going to want to solve quadratics. It's important to know where they're equal to 0 to be able to manipulate them and to see things, because in real life situations, knowing where something's 0 can mean anything from where does something hit the ground if you have projectile motions. So if you threw something off of a cliff, you can say, when did it hit the ground? That would be where it touches the x-axis. That would be where it's equal to 0, because your height would be nothing. So that's when it's touching the ground. So that's why it's important to solve these, is for these real-life situations, because nothing in math is just fun numbers to play with. Very, very high theoretical math is for that, but even then, it's still ultimately used to solve problems. That's what math is. So we're learning this so that we can be able to solve problems like that. For quadratics, factoring is the easiest way to solve that. There's also the quadratic formula, and there are some more difficult cases of factoring, but this is an easy case to get our feet wet before we move into some of the more annoying cases. So the way that we would factor in this case, the first thing you always want to look at is what is my first coefficient. The coefficients are the numbers in front of your variables. In this case, there's nothing here, so our coefficient in front of x squared is 1. That's the easiest case, which is why we're starting with it. Then we need to see what our final term is. Our final term is 6. So we want factors of 6. Part of the reason that we call it factoring. So we're looking for two things that are going to multiply to make our quadratic equation, because once we get to this step, it'll be much easier for us to solve it, and I'll explain that in a second. Bear with me, trust me, and we'll get there. Our factors of 6 are 1 times 6 and 2 times 3. The second part that we need is we need something that adds to make 5. So let's look at our factors again. 1 plus 6 is 7. That's not 5, so we don't care about it. 2 plus 3, on the other hand, that's great. That's what we want. So 2 and 3 are going to be our numbers. So our factors are going to be x plus 2 and x plus 3. Now, we're going to test this just to make sure that we're right, then we'll come back to how to solve this. Now, if you've never multiplied binomials, which is a fancy way of saying multiplying these things, they're called binomials, bi meaning 2, they have 2 terms. X and 3, that's 2 terms. X and 2, that's 2 terms. So we're multiplying 2 binomials. We do something called FOILing. Some people don't like it to call it that, but it's because you do the first, outside, inside, last. So they call it FOILing. Doesn't really matter what you call it. What you do is you have to multiply the first term by both terms in the second part. Then you have to multiply the second one by both terms. So let's go through this. What is x times x? X squared. What is x times 3? 3x. Second part. What is 2 times x? 2x. 2 times 3? 6. Now notice, I multiplied 2 times 3. That's where this 6 is coming from. My 2x and my 3x combining is where my 5x comes from. So, we do, in fact, end up back with x squared plus 5x equaling 6. So, we know that we factored it right. And again, the 6 came from multiplying those two. The 5 came from combining like terms. That's why we're looking for something that adds to 5 and something that multiplies to 6. Because we're wanting to go in reverse from this idea of multiplying our binomials. That's the trick. It's not just some arbitrary thing some random mathematician came up with and said, hey, I bet this is going to work, and then it turned out. It's trying to reverse engineer this process. So, we have our factors. And that's all well and good. But why the heck did we want to change the way this looks? This is an important lesson in mathematics because everything in math can be hard. Despite what your teacher is going to tell you, there's some tough math out there. And quadratics, at one point in time, probably were difficult. And some mathematician figured out how to reverse engineer them so that he can make it easier. Mathematicians are lazy. They don't like to work hard. So, the trick to that is making things look prettier. Here, this is much easier to look at and solve than this thing up here. The reason is because something called the zero product property. So, whenever you multiply anything times 0, it's 0. Where that comes into play is if I were to ignore this and make this 0, it doesn't matter what this piece is right here, because this would be 0. So whatever this is, if I make this 0, 0 times whatever would be equal to 0. Similarly, if I didn't care about this and made this 0, no matter what, times 0 equals 0. So, if I make this piece 0, or if I make this piece 0, both would be solutions for this. This brings us to another important part. Quadratics will have two solutions. Now, eventually you'll get into imaginary numbers and multiplicities, but quadratics are going to have either 0, 1, or 2 real solutions. Now, back to our different shapes. If you have the three different types of quadratics, you can have it where the parabola touches the x-axis twice. You can have it where the parabola touches it exactly once at the vertex. And you can have it where the parabola doesn't touch the x-axis at all. This, because it doesn't touch it, has 0 solutions, 0 places where it touches. This touches in one spot, 1 solution. 2 solutions is where it touches it twice. These are your 3 possible situations. And again, if you flip the parabolas over, because you can have a negative parabola, so something that looks like this, same thing. It's still only going to be able to touch it twice, none, or once. Regardless, you're still only going to have one combination of those. So, in our case, we're going to have 2 solutions. So, let's find them. If I want this piece to be 0, I would say x plus 2 equals 0. If I want this piece to be 0, x plus 3 equals 0. Now we're back into more familiar algebra territory. Here, I have to get my x by itself. So, I have to take 2 away from both sides, because I always do the opposite of what I'm doing. So I'd have x equals negative 2. Here I'd take 3 away from both sides. X equals negative 3. So my 2 solutions are x equals negative 2 and negative 3. Now just for fun, let's plug those in and see if they work. So, x squared plus 5x plus 6 equals 0. Let's test that out. Our answers were negative 2 and negative 3. So let's plug those in. Always, always, always put parentheses around your answer, or whatever you're plugging in. Because even if you put it in a calculator to check, if you plug in negative 2 squared in your calculator, what that's going to say is, what's negative times 2 squared? 2 squared is 4. That would give you negative 4. That's not the right answer. That's how you can make calculator error, which is why it's important to know math, even though you have a calculator. If you don't know what you're plugging in or how to plug it in, it doesn't matter that you have a powerful tool. So, if you're going to use a calculator to test it, always put your thing in parentheses, then square it. Plug in a negative 2 there. Let's see what that equals. Negative 2 squared, negative 2 times negative 2 is positive 4, not negative 4. 5 times negative 2 is negative 10, plus 6. 4 minus 10 is negative 6, plus 6 equals 0. So that one works. Let's try the other one just to be sure. Negative 3 squared, plus 5 times negative 3, plus 6. Negative 3 times negative 3 is positive 9, plus 5 times negative 3 is negative 15, plus 6. 9 minus 15 is negative 6, plus 6 is again 0. So, our answers are correct. So, this is the 2 solutions for where this quadratic is equal to 0. Next time, what we'll look at is a more difficult case where the leading coefficient in front of the x squared is not 1. There's still a way to factor it, it's just a different step, and there's something called factoring by grouping. We'll go into that next time, and then carry on from there. Thanks for watching, and subscribe if you like my videos.